Quadratics. You know equation is quadratic when the highest power is 2. For example, let's look at this example. X squared plus 6x minus 1 is equal to 0. Now, this is quadratic because the highest power is 2. It's quadratic because the highest power is 2. That's all you're looking for. What's the highest power in that equation? And it'll tell you it's 2. Now, look at this one. Let's say we have y equals 3x plus 2. So you have that one. This one is linear. Because x is to the first power. Because x is to the first power. It's linear due to that reason. So if the highest power is 2, it's quadratic. If x is to the first power, it's linear. Now, let's talk about this. The quadratic, let's move it up. Quadratic parent function. Okay. The quadratic parent function is y equals x squared. That's the quadratic parent function. The linear parent function is y equals x. When we're talking about parent functions, we're saying this: all quadratic equations are derived from y equals x squared. All linear equations are derived from y equals x. Those are things that you have to know, and we'll look at the graphs later. But you have to know those things. Now, the graph of a quadratic is a parabola. And now it's parabola. Now, we'll only deal with 2 types of parabola. This one, and this is called facing up, and this one. This one is facing down. And we'll talk about in a few minutes here, how do we know if it's facing up or down? Okay, and of course, the graph of any linear function, the first four letters, is a line. And there's four of those we have already dealt with. Positive slope, negative slope, vertical line, and a horizontal line. Vertical, horizontal. Those four right there. Now, here's what you're going to need to do. You're going to need to draw a big graph on in your comp book. Alright. That looks about the middle. Now, do it in pink. Alright, we've got our graph right here. Label it. Here's your x-axis. And here's your y-axis. Label the axis. Okay, then we're going to draw a parabola. Turn it off. There's your parabola. Draw a parabola. A little better than mine, but make it close. Alright. The parts of the parabola that we're going to do this year. First, this very bottom point right here is the vertex. Starting point. Whenever we graph, that's where we're going to start. So for any parabola that we ever graph, we're going to start at that starting point. Now, this point right here, and we've talked about it, where it crosses the y-axis, that's the y-intercept. Just like when we were graphing lines. That's the y-intercept. So wherever it crosses the y-axis, it's the y-intercept. Now, we've talked about these 2 points here. Where the parabola crosses the x-axis. Put those points there, make it a little bigger. Where it crosses the x-axis is called the x-intercept. It's called the x-intercept. Now, there's 3 other names you need to know. Roots, which is relatively new, solutions, or zeros. Roots, solutions, or zeros. And you will have to know all 3 of those, basically all 4 of those. You will have to know that. Now, the last thing is something you did last year. Draw a dashed line through the vertex. Put your arrows on it. Alright. that dashed line right there, and y'all did this last year, it's called the axis of symmetry. The axis of symmetry. Now, here's what the axis of symmetry does. Divides the parabola in half. Divides the parabola in half. Oops, close brakes. That's it. Well, those are a few of the parts that we're going to label when we start graphing. It divides the parabola in half. Okay, I'm going to have to turn the page here. Okay, so if you still got room, you can stay on that page. If you still have room, I'm going to have to change. Okay. Now, let's talk about the two forms. First one is what we call vertex form. Vertex form is y equals a times x minus, notice I'm putting a minus, h squared plus k. That's vertex form. Now, standard form. Standard form is ax squared plus bx plus c is equal to 0. I forgot this. Now, let's come back over here to vertex. I forgot to add this. Where hk is the vertex. Very important, because that's where we start graphing. That's very important. Where hk is the vertex. Now, I'm going to give you some examples of this. Yeah. Let's look at this one. Here's an example. Let's say you have y equals 2 times x minus 4 squared minus 2. You're given that equation right there. Your vertex would be 4, negative 2. For this reason, in your formula, that's a minus. It's like the point slope formula. We had to deal with a lot of minuses. So it's 4, negative 2. Because you put a positive in there, it's still going to remain positive. Now, look at this one. Y equals 3 times x plus 2 plus 5. Oops, forgot the square. So the vertex here would be negative 2 5. That would be the vertex. That's your vertex right there. Now, and we will talk more about that later. Okay, now, look at this. They both have an A. And A determines a couple of things for each parabola. So, let's talk about A for a minute. A determines how wide or narrow a parabola is. Determines how wide or narrow a parabola is. Now, if A is positive, the parabola will face up. If A is negative, the parabola will face down. And I showed you face up and face down when we were talking about the parabolas. So those are that is just one thing that A does. Now, here's the other thing. We're still talking about A. Determines, let's change that. I jumped, I need something to mark this out. Determines which way a parabola faces. I knew something was off. Determines which way a parabola faces. So if A is positive, it faces up. If A is negative, it faces down. Now let's put in determines how wide or narrow it is. Determines how wide or narrow a parabola is. Now, when we're determining that, when comparing two or more equations, when comparing two or more equations, you must take the absolute value of each. So when we get to that, you must take the absolute value of each. That must be done. That has to be done. Now, let me give you the definition of absolute value. Here's the definition of absolute value. The distance a number is from 0. The distance a number is from 0. That's all the definition of absolute value is. Now, here's an example, because you need to see what it looks like. These bars mean absolute value. Absolute value of 2 is 2 units from 0. So the absolute value of 2 is just 2. It's just 2 units from 0. Now, the absolute value of -4, how far is 4 from -4? It is 4. It's 4 units from 0. And when we start taking the absolute value, you need to know those things.